Hello students, in this video I am going to discuss the MCQ type problems based on the topic linear differential equation. Linear differential equation, basically this particular topic is divided into two parts. The first part containing the homogeneous linear differential equation and the second part containing non-homogeneous linear differential equation. So in this particular video, our prime focus is to discuss the problem based on the homogeneous part of the linear differential equation. So let us start with the problem based on this topic. Let us start with the first problem. In this case, we are given three differential equations, A, B, and C. And the question is, which of these represent a differential equation with constant coefficient? Basically, the general representation of the linear differential equation is A naught nth order derivative of y plus A1 nth n minus 1th order derivative of y plus so on A and y is equal to Rx. This is the general representation of nth order linear differential equation. So if Rx is equal to 0, that means if there is no term other than the dependent variable and its derivative, then that differential equation is said to be homogeneous linear differential equation. And second thing is here these coefficients A0, A1, A2, so on An, they may be constant or they may be function of x. So if all these coefficients are constant, if A0, A1, A2, so on An, if all are constants, then the differential equation is said to be a linear differential equation with constant coefficient. With constant coefficient. If any one of them, if any one of them is a variable, then that type of differential equation is said to be a linear differential equation with variable coefficient. So if we look at here in the very first equation, here the coefficient of y triple dash is 1, the coefficient of y double dash is 3, the coefficient of y is 12. This is a non-homogeneous part of a differential equation. Our concern is the coefficient. Here the constants coefficient. Here the coefficients are constant. So it means that this is a differential equation with constant coefficient. And here you can see here x cube, which is a variable. X is also variable. So it is a differential equation with variable coefficient. And here also the coefficient of y double dash is 1. Coefficient of y is a square, which is again a constant. Okay, so it is again a differential equation with constant coefficient. So in this case, we find that A and C, both these two differential equations are differential equation with constant coefficient. In this case, the correct answer is option B only, right? Okay, so now we move to the next question. So in this case, let me just increase the font size. Right. So in this case, we are given a differential equation x into 1 minus x y double dash minus 3x y dash minus y equal to 0. So we are interested to find out an interval in which the given differential equation is normal. So firstly, what is the condition here? So if the differential equation is of the type like it is a second order differential equation, so I am considering a naught y double dash plus a1 y dash plus a2 y equal to rx. This is a differential equation. Then we can say that the differential equation is a normal in some interval I if the condition is coefficient a0, a1 and a2 and including the non-homogeneous part, that is a0, a1, a2 and rx, all these functions are continuous. They should be continuous in the interval I. They should be continuous in interval I. And the second condition is that leading coefficient should not be equal to 0 in interval I. So if there exists some values of x for which all these functions are continuous and your leading coefficient is not equal to 0, that particular values of x or that interval for which the given differential equation is normal, or we can say that there exists a unique solution of this differential equation in that interval. Okay, so what we are going to do is simply compare the given differential equation with this standard one. So this coefficient is your a naught, which is the leading coefficient. This coefficient is a1, and here this coefficient is a2, and your right hand side rx is 0. That means on comparing with the given differential equation, on comparing this differential equation with the given one, we'll get the leading coefficient a naught is x into 1 minus x, and the coefficient a1 is minus 3x, and the coefficient a2 is minus 1, and rx, which is equal to 0. So firstly, if we talk about the condition of continuity, so you can see here a naught being a polynomial function and a1 being a polynomial function, they are always continuous. So a naught and a1, they are continuous, and because in this case we are not given any interval, so in general we are considering the complete real line as an interval I. Okay, so that is the biggest interval. So they are continuous in the interval for all values of x. Okay, so these two functions are continuous for all x belongs to set of real number. And if we say that a2 being a constant function and rx, these two functions are also continuous, being a constant function, right? They are also continuous for all x belongs to set of real number. Okay, so we can see in this case we are not going to check the condition of continuity. We know that there are some functions which are obvious functions. They are continuous. For example, polynomial function, they are continuous. Trigonometric sine and cosine function are continuous. If we are given rational function like x upon 1 plus x, this function is continuous for all values of x except your denominator should not be equal to 0, right? Sometimes we are given logarithmic function. Logarithmic function is continuous for all x greater than 0. Exponential function, it is continuous for all x belongs to real number. Sine and cosine function, they are also continuous for all real number, right? So in this case, we can use the basic definition. We can check the condition of continuity directly, right? So, so in this case, all the functions are continuous. So that means that the first condition is satisfied for the complete real line. And the second condition is your leading coefficient should not be equal to 0. So here your leading coefficient is a naught. What is a naught? A naught is x into 1 minus x. So it should not be equal to 0. What does it mean? It means that x should not be equal to 0 and x should not be equal to 1. Because for these two values of x, your leading coefficient is 0. So if we take the intersection of all the intervals, so what do we say that? It means that the given differential equation, the given differential equation is normal in the interval. What is the interval? It is the r minus these 2 points 0 and 1. So in other words, we can say that it is minus infinity to 0 union 0 to 1 union 1 to infinity, and this is the biggest interval for which your differential equation is normal. So it may be possible that we are given only this interval, or we are given only this interval, or we are given only this interval. So this is the biggest interval or largest interval for which the differential equation is normal. So we can say that the differential equation is normal in this interval or any sub interval of this interval, right? So in this case, the correct answer is option D only. Okay, so like in this case, we are given the complete interval. Sometimes we are given the sub interval. Like if this option is not there, if we are given 0 to infinity, then we can opt this one. But obviously, this is not the correct answer because 0 should not belongs to this interval, because if x is equal to 0, then your leading coefficient is 0. And for this one, this is again not the correct one because 0 and 1 belongs to the interval R. So if this option is not given here, then we can pick this particular option also, because this is one of the sub interval of this interval. But because we are given option D, so the most suitable option is option D only in this case, right? Okay. Now let us move to the next question. So here the question is the linear independent solution of the differential equation y triple dash minus 7y dash plus 6y equal to 0. Basically, it is a third order differential equation, right? So when we'll try to find out the solution of this equation, so in this case, we can use the operator method. So firstly, we write the equation in the operator form, which is d cube minus 7d plus 6 times y equal to 0. Here we are assuming d as a differential operator d by dx. Then we are assuming let y equal to e raised to the power mx be its solution. Okay, so we'll get the auxiliary equation as auxiliary equation is obtained by simply replacing d with m, and we drop this dependent variable y. So we can get here the auxiliary equation as m cube minus 7m plus 6 equal to 0. It is a cubic polynomial, right? And in case of cubic polynomial, we have a 3. If we write the general cubic equation, the general cubic equation is of the form m cube minus 0m square plus 7m minus of minus 6 equal to 0. Okay, so basically the coefficient of m square gives us the sum of the root, and this coefficient of m gives us sum of root taken two at a time, and this constant term gives us the product of the root, right? So what do we get here? The product of the root is minus 6. Okay, because if we are assuming all the root as positive, then this kind of sign will get here. So here the product of the root is minus 6. Okay, so we need to get an idea that this we need to find out three numbers so that the sum of the root is 0 and the product of the root is minus 6, because we are given here the option. So we'll try to pick, like we have assumed that e raised to power mx be the solution. So if we look at the first one, what are the values of m in the first option? In the first option A, the value of m is minus 1 and 2 and minus 3, right? If we take the sum of the root, the sum of the root is minus 1 plus 2 is 1, 1 minus 3. That is minus 1 plus 2 minus 3. It is equal to minus 2. Obviously, it is not equal to 0. Now, if we consider second one, the value of m is 1, minus 2 and 3. Again, if we take this sum, 1 minus 2 plus 3, it is again 2, which is not equal to 0. Now, in the third option, it is minus 1, 2 and 3. So if we take their sum, minus 1 plus 2 plus 3, it is 4, again not equal to 0. And if we take option D, it is 1, 2 and minus 3. So 1 plus 2 is 3, 3 minus 3 is 0. So yes, it satisfies the condition. Also, if we take the product is 1 into 2 into minus 3 is minus 6. So it means that this satisfies the condition. So the correct answer is option D only, right? But otherwise, if we want to check that what are the root of this polynomial, what can we do? Firstly, we take the sum of the coefficient of odd power term. Sum of the coefficient of odd power term, like the coefficient of m cube is 1, the coefficient of m is 7, it is 8. And if we take the sum of, sorry, here it is minus 7, right? Because the coefficient of m is minus 7. So 1 minus 7, 1 minus 7 is minus 6. The sum of odd power term is minus 6, and sum of even power term, this is equal to 0, and this is plus 6. It is 6. So we take sum of odd power term plus sum of even power term, it is 0. So it means that 1 is the root of this polynomial. So we get that 1 is a root of this polynomial. So one of the root is known. So we can find out the depressed polynomial by dividing the given equation by m equal to 1. So m square, m and constant. We are using the synthetic division rule for finding out the depressed equation. So the coefficient of m cube here is 1, coefficient of m square is 0, coefficient of m is minus 7, and the constant term is 6. Because we find here that m equal to 1 is a root, so we are going to divide it with 1. Okay, so in this case, because 1 is a root, so it means that your remainder term should be 0. So how the process take place? So the first step is we are taking this leading coefficient as it is here. This is 1. And now the division is whatever the most recent number available here this side, we multiply this number with this one and place it in the next step. 1 into 1 is 1. So I place it here. Now adding, it is again 1. Again 1 into 1. Now this is the most recent number which is available here. 1 into 1 is 1. Now I write here again adding, it is minus 6. And now this is the next most recent number available here. 1 into minus 6 is minus 6 and adding 0. So it shows that m equal to 1 is the root of this polynomial, which we have already get an idea. So the depressed equation is these are the coefficient of constant m and m square. Because the given equation is cubic polynomial, we divide it with a linear, so the depressed equation is a quadratic polynomial. So the quadratic polynomial is m square plus m minus 6 equal to 0. So it is a quadratic polynomial, we can easily factorize. The product is minus 6 and sum is plus 1. So m square plus 3m minus 2m minus 6 equal to 0. So we can factorize it as m plus 3 or minus 2 taken outside, m plus 3 equal to 0. So m plus 3 and m minus 2 equal to 0. So the value of m comes out to be 2 and minus 3. So one of the root is 1, other two roots are 2 and minus 3. So what is the general solution? So the general solution is the linear combination, because we have assumed e raised to power mx be the solution. So one solution is e power x, other solution is e power 2x, and the third solution is c3 e power minus 3x. Or we can say that the linear independent solution are e power x, e power 2x, and e power minus 3x. So again, we'll get the correct answer as option D only. Okay, so the shortcut method is that we can see here the sum of the root is 0, product of the root is minus 6, and minus 7 is the sum of root taken 2 at a time. Means 1 into 2 plus 2 into minus 3 plus minus 3 into 1. This is 2 minus 6 minus 3. So minus 9 plus 2 is minus 7. So you can verify here. This represents sum of root taken 2 at a time. This is the product of the root and this is the sum of root. So sum of root is 0. Sum of root taken 2 at a time is minus 7. Product of the root is minus 6. So in this case, it satisfies all the conditions. So we can say that this is the solution. But otherwise, if we are not getting this idea, then we firstly find out that either 1 is the root of this polynomial by taking the sum of odd power term and even power term. If their sum is 0, it means 1 is a root. If their difference is 0, it means minus 1 is the root of the polynomial. Okay, so we can use this concept. Okay, now let us move to the next question. So the next question is, we are interested to find out the differential equation of this form for which these two functions are the solution. Okay, again, there are two ways to find out the solution of this problem. One is because it is given that these two are the solution, so it means that they must satisfy this equation, right? Like we are assuming y equal to e power 3x is the solution. So what is y dash? 3 times e power 3x, y double dash. It is 9 times e power 3x. So because y equal to 3x is a solution, so it must satisfy the given differential equation. So I'm replacing y double dash with the 9 e power 3x plus ax times y dash 3 power 3x plus bx times y. Y is e power 3x equal to 0. So e power 3x taken outside, we can get 9 plus a plus 9 plus 3a plus b equal to 0. Obviously, this is not equal to 0. It will give us the first equation as 3a plus b plus 9 equal to 0. Now, also we are given e power minus 2x is the solution. So if Now we consider y equal to e power minus 2x. Y dash is minus 2 times e power minus 2x. Y double dash is 4 times e power minus 2x. Now if we substitute this value in equation number 1, then your equation number 1 become y double dash is 4 times e power minus 2x plus ax into y dash, that is minus 2 times e power minus 2x plus bx times y e power minus 2x equal to 0. So e power minus 2x taken outside, it will gives us 4 minus 2a plus b equal to 0. Of course, exponential function is not equal to 0. It gives us minus 2a plus b plus 4 equal to 0. So now we are having two equations with two unknowns. We solve them simultaneously, we can get the value of a and b. Like 3a plus b plus 9 equal to 0, minus 2a plus b plus 4 equal to 0. We are subtracting, this is plus, this is minus, this get cancelled out. So 5a plus 5 equal to 0, the value of a comes out to be minus 1. If a is minus 1, so we can consider here 3a plus b plus 9 equal to 0. So 3 into minus 1 plus b plus 9 equal to 0. So b minus 3 plus 9 is 6. The value of b is minus 6. So if we replace here, you will get the equation number 1 as y double dash minus y dash minus 6y equal to 0. So the correct answer is option D. This is one of the way to get the solution of this problem, right? The other one is because you can see here, like when we have a differential equation with constant coefficient, because all the four options are constant only. And we know that in case of constant coefficient, we are assuming e raised to power mx with the solution. So if we compare here, we can get the value of m as 3 and minus 2. If these are the root of the auxiliary equation, then what is the differential equation? Then the differential equation is d minus m1 into d minus m2 into y equal to 0. Right? If root of the auxiliary equation are this, then this is the differential equation, right? Because if you can see in the last question, when we write the auxiliary equation, basically if the uh, auxiliary equation is m cube minus 7i plus 6 equal to 0, then the differential equation is d cube minus 7d plus 6 into y equal to 0. That means we simply replace the d with m, or in reverse we can replace m with d to get the differential equation from auxiliary equation. Okay, like here we can say that if m equal to 3 and m equal to minus 2 are the root, then m minus 3 and m plus 2 equal to 0 is a factor, or m square minus m minus 6 equal to 0. This is the auxiliary equation. And what is the differential equation? D square minus d minus 6y equal to 0, or y double dash y dash minus 6y equal to 0. So same we can get here, d minus 3 d plus 2 y equal to 0. So it means d square minus d minus 6 y equal to 0. Here d represents the differential operator. So in both the ways you come out with the correct answer. So you can choose that which of the option is more suitable for you. I think that if you will find that the roots are real, if the root of the auxiliary equations are a real root, then it will be preferable. Then we can choose this method, right? Otherwise, this is also one of the way to find out the differential equation. Okay, now let us move to the next question. Okay, so we this time we are given a fourth order differential equation, and we are interested to find out the general solution of the differential equation. Okay, now let us see here. So if we write the equation in the operator form, and this is fourth order, third order differential equation, second order, and this is first order, where d stand for the differential operator d by dx, right? Okay, so again we are assuming let y equal to e raised to power mx be its solution, then we can get its auxiliary equation as m power 4 minus 6 m cube plus 12 m square minus 8 m equal to 0. So you can see here m is common throughout. So m cube minus 6m square plus 12m minus 8 equal to 0. So from here we get an idea that one of the root is 0, m equal to 0, and rest is a cubic polynomial 6m square plus 12m minus 8. So one of the root is 0, and now to find out the other three root. So here we find that we have an alternate sign, plus, minus, plus, minus. So it means that all the roots are either positive or some of the root are complex also. And here the constant term is 8. So 8 means that the possible factorization of 8 will be either it is 2, 2, 2, or it is 2, 4, 1, or it is 8 into 1 into 1. So firstly we'll check that either 1 is a root. You can see 1 it means sum of odd power term is 1 plus 12 is 13, and sum of even power term is minus 6 minus 8 is minus 14. So you can see here neither their sum is 0 nor their difference is 0. So it means that 1 and minus 1 is not the root of this polynomial. So it means that these two options are not possible. So this, let us try this one. 2 into 2 into 2 is 8, and if we take their sum is 6, sum of the root is 6, rest satisfied, and 2 into 2 plus 2 into 2 plus 2 into 2. 2 into 2 4, 4 plus 4 plus 4 is 12, yes it is 12. So it means sum of root taken 2 at a time is 12. So it means that the root of the auxiliary equation are 2, 2 and 2. So one of the root is 0, other three roots are same. So we know that if the roots are, one of the root is 0, so c1 e power 0x. And if the root is repeated, how many times root is repeated? 3 times. So if the roots are repeated, we are going to multiply e raised to power mx with the basis of the polynomial function like 1, x, x square, x cube and so on. It depends that how many times the root is repeated. So if it is repeated 1 time, e raised to power mx into 1. If it is repeated 2 times, 1 and x. If it is repeated 3 times, 1x x square. That is, solution is c1 e power c2 e power 2x, c3 x time e power 2x, c4 x square time e power 2x. Or we can write c1 c2 plus c3x plus c4 x square time e power 2x. So let us see which of the option is correct one here. Right, the correct option is option D only, because three roots are 2 and one time root is 0. So obviously these are not the correct option. Okay. So either you can do this way, or otherwise we can get an idea that one of the roots should be 2. Like you can substitute here 2 cube is 8 minus 6 times 2 square plus 12 times 2 minus 8. So it is 8 minus 24 plus 24 minus 8. So cancel out, it means that one of the root is 2. So then you can divide it with the m equal to 2. So m cube, m square, m and constant. Its coefficients are 1, minus 6, 12 and minus 8. When we divide it with 2 using synthetic division rule, this 2 1 leading coefficient as it is. 2 into 1 is 2, it's minus 4. 2 into minus 4, minus 8, again 4. 2 into 4, 8, it is 0. So these are the coefficient of m square, m and constant, which is nothing but m minus 2 whole square. Automatically, one of the root is 2, other two roots are also 2, 2. So the roots are 2, 2, and 2. And one of the root is 0. So these are the root of the auxiliary equation. Hence, you can get this solution. Okay. Okay, now let us move to the next question. In this case, we are given the differential equation, but with variable coefficient, and it is given that one of the solution is given, and we are interested to find out the other linear independent solution, right? Okay, so in that case, we have one formula. Like if we have a differential equation of second order, like a naught y double dash a1 y dash plus a2 y equal to 0, and if y1 is one of these solution, then the other solution, other linear independent solution, is given by the formula y2 equal to vy1, where v dash is given by 1 upon y1 square e raised to the power minus a1 upon a naught. Okay, so if we compare it with the given differential equation, then this is your a naught, this is your a1, and this is your a2, and this is your y1. So what is a naught? Is 1 plus x square. A1, it is minus 2x, and y1 is x. So with the help of this formula, firstly we calculate v dash. So what is v dash? Equal to 1 upon y1 square e raised to the power minus a1 upon a naught dx. Y1 is x, so it is 1 upon x square e raised to the power minus a1 is minus 2x upon 1 plus x square dx. This negative sign get cancelled out. Now it is of the form integral f dash x upon f of x dx. And we know that its solution is mod of f of x plus c, because if your function is 1 plus x square, then its derivative is 2x. Okay, so in the denominator we have a function, here we have a derivative of the function, so this is the formula. So we are considering 1 upon x square e power log of 1 plus x square. We are not choosing here the constant of integration here, because we are interested to find out the linear independent solution only. Okay, so we are simply considering the function, we are not adding arbitrary constant. So exponential and logarithmic function, they are inverse of each other, so we'll get 1 plus x square upon x square, so it will give us 1 upon x square plus 1. This is the value of v dash. So if v dash is known, what about v? It is the integral of v dash, that is integral of 1 upon x square plus 1 dx. So integral of 1 upon x square is minus 1 upon x plus x. Again, we are not adding constant of integration. So what is the value of y2? This is v times y1. V is x minus 1 upon x. And what is y1? Y1 is x. So it is x square minus 1. So what is the other linear independent function? X square minus 4. So this is the solution. Otherwise, the general solution will be c1 y1 plus c2 y2. That is c1 into x, c2 into x square minus 1. This is the general solution of the differential equation. But we are interested in only the other linear independent solution. So other linear independent solution is simply x square minus 1. So you can remember this formula. If one of the solution of the differential equation is known, to find out the other linear independent solution, this is the formula y2 equal to v y1, where v dash is 1 upon y1 square e raised to the power minus a1 upon a naught dx. Okay, let us move to the next question. So here we are given a second order differential equation, and we are interested to find out the general solution of the differential equation. So second order differential equation, we firstly write it in the operator form. It is d square plus 1 into y equal to 0, where d stand for the differential operator d by dx. We are assuming let y equal to e raised to power mx be the solution. So its auxiliary equation is given by m square plus 1 equal to 0. So if m square equal to minus 1, square of a number is negative, it means that it is a complex number. So m equal to plus minus square root of minus 1, that is plus minus iota. So we get here real part is 0 and imaginary part is 1. And we know that if the root of the auxiliary equation are complex, a plus minus iota b, then the solution is a e power ax, a cos bx plus b sin bx, where a and b are arbitrary constant. So if we compare here, what is a? Here a is 0 and here b is 1. So we can get the solution as e power 0x, a time cos x plus b time sin x. Or simply we can write here a cos x plus b sin x. Because a and b are arbitrary constant, so I can replace a and b with p and q also. So it means that the correct answer is option A, because here p and q are arbitrary constant. They are arbitrary constant. Okay, this is a simple rule. Now let us move to the next one. Okay, so the question is we are given a differential equation and we need to identify that which of the following is the solution of the differential equation. So here we are given the value of p and q are 4 and 3. Basically, in this question is based on 3 different parts. From the first part, we need to identify the value of p and q, and then we are going to use this particular value in the next part. Okay, so because that part is not related to our topic, so I just skip that particular part. So here we are assuming that the value of p and q are known to us. So it means that your differential equation is basically can be rewritten as d square plus p time d plus q plus 1 time, here basically y is missing, time y equal to 0. So I can write it as d square, p is given as a 4 and q is given as 3 plus 1 is 4 and y equal to 0. Of course, here d stands for the differential operator. So we are assuming let y equal to e raised to the power mx be its solution. So its auxiliary equation is m square plus 4m plus 4 equal to 0. Quadratic polynomial, sum of the root is 4, product of the root is 4, and 4 can be written as 2 square, and 2 plus 2 is 4. So basically this is m plus 2 whole square equal to 0. Okay, we can otherwise find out using the formula ax square plus bx plus c is the quadratic polynomial, and the value of x is obtained minus b plus minus discriminant, that is b square minus 4ac upon 2a. So if the discriminant, that is b square minus 4ac is greater than 0, roots are real and distinct, roots are real and distinct, and if discriminant, that is b square minus 4ac is equal to 0, it means that roots are real and equal, and if discriminant, that is b square minus 4ac is less than 0, then the roots are complex. Okay, like in the last question, here we find that the discriminant is negative. If you can use that formula, we'll find out discriminant is negative. That's the reason here the roots are complex. And in this case, you can find out the discriminant is 0 because b square is 16, 4ac is 16, so 16 minus 16 is 0. So the roots are real and equal. So the value of m comes out to be minus 2 and minus 2. So if the roots are repeated, then we need to, because we have assumed e raised to power mx be the solution, then the solution is c1 e power minus 2x. And because it is repeated, we need to multiply it with the basis of the polynomial. Then the second one is x times e power minus 2x. Or you can simply write c1 plus c2x e power minus 2x. Okay. So we need to find out that which of the following represent a solution. E power minus 3x not a solution. E power minus x is not a solution. E power minus 2x is a solution, but x square means that root is repeated 3 times. But root is repeated 2 times only, so again it is not the option. So the correct answer is option C only. Okay, that means if we assume C1 equal to 0 and C2 equal to 1, then you can get the solution as x e power minus 2x. It is not possible to get x square because x square is obtained if we get a root is repeated 3 times. But it is not possible because we are given a differential equation of order 2 only. So it has at most 2 linear independent solutions. Okay, now let us move to the next one. Here we are given a differential equation with the boundary conditions and we need to find out the value of y at the value 0.5. Okay, let us see. So firstly we write the equation in the operator form d square plus 2d plus 1 into y equal to 0 where d stand for dy dx. Second order d square, first order d, no derivative, so it is simply constant. Okay. So we are assuming let y equal to e raised to the power mx be its solution. So we'll get its auxiliary equation as replacing d equal to m square plus 2m plus 1 equal to 0. Again, product of the root is 1, sum is 2. 1 plus 1 is 2, 1 into 1 is 1. So it is m plus 1 whole square or m equal to minus 1 and minus 1. Or you can see here what is b is 2, what is c it is 1, what is a it is also equal to 1. So b square minus 4ac, 2 square minus 4 into 1 into 1, 4 minus 4 is 0, so the roots are real and equal. And what is the value of m? Minus b plus minus square root of b square minus 4ac upon 2a. So this is minus 2 plus minus 0 upon 2 into 1. So minus 2 upon 2 minus 2 upon 2. So its value is minus 1 and minus 1. Okay. So the roots are real and repeated. So the solution is c1 plus c2x e power minus x. Okay. If the root repeated 2 times, we get a linear polynomial. If the root is repeated 3 times, we get a quadratic polynomial. If 1 time, then it is simply c1 e power mx. Now we are given here the boundary conditions. So the boundary condition first one is y of 0 equal to 0 means when x equal to 0, y equal to 0. So we are assuming yx as c1 plus c2x e power minus x. So y of 0, it means c1 plus c2 into 0 into e power minus 0. So 0 equal to c1. So what do we have? We left with yx equal to c2 x e power minus x. The other condition is y of 1 equal to 0. Now y of 1 is c2 into 1 e power minus 1. Again it is 0. Now e is not equal to 0. The only possibility is c2 is 0. If c2 is 0, that means y is equal to 0. And if y equal to 0, then automatically y of x is 0 means for all values of x its value is 0. So automatically at 0.5 its value is also 0. So the correct answer is option A. So in case of initial or boundary condition, after finding out the general solution, we need to apply these conditions also. Okay, now let us move to the next question. So consider two solutions of the differential equation such that x1 0 equal to 1, its derivative is 0, x2 0 is 0, its derivative is 1. Then we are interested to find out Wronskian at the point pi by 2. Okay, so firstly we need to find out its linear independent solution. So the differential equation in operator form is d square plus 1 x equal to 0. Now but here d stand for d by dt because our independent variable is t here. So we are assuming let x equal to e raised to the power mt be its solution. So its auxiliary equation is m square plus 1 equal to 0. So m square equal to minus 1. Square of a number is negative, it means roots are complex. So the value of m is plus minus square root of minus 1, that is plus minus iota. Real part is 0, imaginary part is 1. So solution is a cos t plus b sin t. Not y, but it is x. So what is one of the solutions? So one of the solutions say x1 is cos t and x2 is equal to sin t. But we need to choose in such way so that they must satisfy this condition. So what is x1 0? When t equal to 0, cos 0 is 1. And what is x1 dash? It is minus sin t. So x1 dash 0 is sin 0 and sin 0 is 0. Okay, satisfy both the conditions. Similarly, what is x2 0? x2 0 is sin 0, it is 0, and x2 dash is cos t, and x2 dash 0 is equal to cos 0 is equal to 1. So it means that like when we are writing the solution, we can assume sin t and cos t also, but we need to choose the solution in such way so that they must satisfy this condition. Okay, so what is x1 cos t, what is x2 sin t? So now we need to find out Wronskian of x1 and x2. So this is x1, x2, x1 dash, x2 dash. x1 is cos t, x2 is sin t, x1 dash minus sin t, x2 dash cos t. So we need to find out its value at t equal to pi by 2. Although it is constant, cos k t plus sin k t, its value is always equal to 1. So even if we calculate its value at t equal to pi by 2, still its value is 1 only because it is already constant. So answer is option A. Even if we put directly, what is cos pi by 2? Cos pi by 2 is 0, sin pi by 2 is 1. So even if we calculate by substituting its value, then in both the ways we can get the value 1. Okay. Now let us move to the next question. Question is if the particular solution of the homogeneous linear differential equation with constant quotient is this, then the lowest order of the differential equation is. Now we are given a particular solution x square e power 2x. Particular solution is a particular solution is basically obtained from the general solution, okay, by assigning some initial or the boundary condition, right? So in this case, it may be possible that some of the arbitrary constant will be 0. So in this case, we are interested to find out the lowest order of the differential equation for which this function has a solution. So let us firstly try to identify the general solution. So the general solution. So we have e power 2x, but beside this we have an x square. We know that we'll multiply it with x or x square when the root is repeated. So basically x square means that it is a quadratic polynomial. It should be of this type. And here it is 2 times e power minus 2x. That means it is e power minus 2x is the another solution. So how many constants are there? One, two, three, four. It means that the order of the differential equation is 4. Okay, like, because what are the root of the auxiliary equation? In this case, we'll get 2, 2 and 2 and minus 2. These are the root of the auxiliary equation. And if we want to find out the differential equation, then the differential equation is d minus m1, d minus m2, d minus m3, and d minus m4 into y equal to 0. So this is d square minus 4d plus 4 into d square minus 4 into y equal to 0. Okay, and you can take the product, you will get a fourth order differential equation. Okay, but in this case we are interested to find out the order only. So how do we get the order? We get here x square. X square means that definitely this root is repeated at least 3 times. It may be possible that x cube coefficient is 0, but we are interested to find out the lowest order differential equation. That means that must satisfy this equation. So x square means that that root must be repeated at least 3 times. C1 plus C2x plus C3x square and e power 2x, and another root is e power minus 2x. So in this case the order is 4, and if we want to find out the differential equation, we can take the product of these two. You will get the required equation. Okay, now let us move to the next one. Okay, so if Wx is the Wronskian of the solution of a differential equation, then what is the Wronskian of x? So there are two ways to find out the solution. One is we need to find out firstly the solution of this differential equation, but it is a differential equation with variable coefficient. Although it is the Euler-Cauchy form, which is a part of unit number 3 also, right? In that case, if we want to reduce this equation into a differential equation with constant coefficient, then what can we do? We can choose the trial solution as, or we can make a substitution, put log of x equal to t or x equal to e power t, right? The reason is because we need to convert this differential equation into differential equation with constant coefficient. Now x y dash, basically it means x dy by dx. So I want to make this x as a constant. So I can take it as dy upon 1 upon x dx. So this can be considered as dy by derivative of log of x. So it means that if we make this substitution, then automatically this variable can be removed. So if we use this transformation, then our differential equation reduces to a differential equation with constant coefficient. So in that case, x y dash is reduced to theta y, where theta stands for d by dt, and x square y double dash is replaced with theta into theta minus 1 into y, right? So if we use this, then your differential equation reduces to theta into theta minus 1 minus theta minus 3 into y equal to 0. That is theta square minus theta minus 3 into y equal to 0. So theta square minus 2 theta minus 3 equal to y equal to 0. So we assume let y equal to e raised to the power mt be its solution. So its auxiliary equation will be m square minus 2m minus 3 equal to 0. Sorry. So in this case, the product of the root is 3, which is the prime number, and sum is minus 2. So I can write it as m square minus 3m plus m minus 3 equal to 0. So m minus 3 so m plus 1 m minus 3 is equal to 0. So the value of m comes out to be minus 1 and 3. So roots are real and distinct. So the solution will be c1 e raised to the power minus t, c2 e power 3t. And because we have assumed log x equal to t, so what is x? X is e power t. So it means solution is x power minus 1 and x cube. So what are the solution here? Basically solutions are 1 upon x and x cube. So what is the Wronskian of x? So Wronskian of y1 and y2. This is y1, y2, y1 dash, y2 dash. So this is 1 by x cube. Its derivative is minus 1 by x square. Its derivative is 3x square. So on solving this, we will get 3x. This is x. So its value is 4x. So the correct answer is option B. So you can see here it is a quite lengthy process because firstly we need to transform this differential equation into a differential equation with constant coefficient. Using this transformation, find out its complementary function, that is the solution of homogeneous differential equation. And after getting the solution, we need to find out the Wronskian. But there is another alternate method also, which is the Abel's formula. Abel's formula states that if you have a differential equation of the type a naught y double dash plus a1 y dash plus a2 y equal to 0, then the Wronskian of a solution is given by some constant multiple of e raised to the power minus a1 upon a naught dx. So if we compare, what is a naught? This is your a naught, this is your a1. So what is Wronskian of x? It is constant multiple of e power minus. What is a naught? A1 is minus x. What is a naught? X square dx. It is c times e power integral of 1 upon x, that is e power log x, that is c into x, because exponential logarithmic they are inverse of each other. That is constant multiple of x. So this is not constant multiple of x, this is not constant multiple of x, this is not constant multiple of x. So the correct option is for x only. Okay. So in this case, with the help of Abel's formula, you can directly get an idea about the Wronskian of the function. So you have a choice, either you can use this method, firstly reduce your differential equation into constant coefficient, find out the solution, and then calculate the Wronskian of a function, or you can use the shortcut formula for calculating the Wronskian of a function. Okay, so that's all from my side, the problems related to the homogeneous linear differential equation. So soon I'll share with you the video based on the linear differential equation with variable coefficient. Thank you all of you. Have a nice day.